Good day, my dear IEM sons and daughters. Today, we wish to deliver a lecture on simple pendulum and simple harmonic motion, together with the slight introduction of string. Now, simple pendulum is very well known to you. You read it in class 12. But we want to probe deeply and see depth into the nature, what this thing says, what I know, and what is the knowledge addition with respect to very simple pendulum we know in physics from class 12. Let us, before doing it, we must understand two very important things of class 12. One is, if there is a force P and makes an angle theta with x-axis, then along x-axis force is P cos theta, together with along y-axis force is P sin theta. This is x-axis and this is y-axis. You may also say, well, if it is arbitrarily oriented, that is always possible. That I do now. Suppose you are going to take a force arbitrarily oriented P, and this is not x-axis, this makes an angle theta. Then along this line the component is P cos theta, together with perpendicular to this line the component is P sin theta. This is called the resolution of forces of basic statics of class 12. Another important thing I must remember, weight acts vertically downward. Third, if there is a weight mg, if there is a string T, then tension acts away from the body. This is also important. Fourth is Newton's second law. I know P equal to mf. I discussed it, my sons and daughters. Therefore, P plus minus mf equal to 0. What does it indicate? If I apply a force P in this direction, minus means in the opposite direction. Minus mf is opposite direction. 0 means the body is at rest. I repeat, I know P equal to mf, therefore P plus minus mf equal to 0. It means if I apply a force P, minus means in opposite direction, mass times acceleration, 0 means rest. The body is at rest. That is, all dynamical problem can be reduced to statical problem, which is very easy to solve. Sigma x equal to 0, sigma y equal to 0, and sigma m equal to 0. You know it already. Next question, that is also very important. P equal to mf is linear. What it would be if it is angular? This I also know from class 12. P is replaced by torque T, m is replaced by moment of inertia I, and linear acceleration is replaced by angular acceleration. F is linear acceleration. If the body moves in x direction, due to x due to alpha in the same way, angular acceleration due to theta due to 2. It comes from s equal to r theta. If I derive once with respect to t, I get v equal to r omega, and again I differentiate with respect to t, then ddt of v is alpha, and it is again angular acceleration is v angular, that is linear acceleration, that is linear acceleration f is r into alpha. Very important thing to remember. But remember, it is force and it is torque. It is force and it is torque, angular. With this very simple understanding, we are now discussing very well-known thing known as simple pendulum. I know from class 12. What is simple pendulum? A simple string is here. This string is inextensible. The string has got no mass. It makes an angle theta with y-axis. A very small heavy particle mg is acting vertically downward. Now, since this is the tension T, acts away from the body. Second is, this angle is theta, therefore this angle is also theta. Therefore, along the string is mg cos theta, perpendicular to the string mg sin theta, and mg abolishes. Therefore, I write this is mg cos theta, this is perpendicular mg sin theta. The string is not extended, that is inextensible, and string is also massless. But it is joined at that hinge. Hinge must have some reaction. The reaction of the hinge A is simple. This is the point A, this is XA, and that is YA. Now, the body moves in this direction. I must apply torque in the opposite direction to make it rest. It is I alpha, as I told you already, and I is moment of inertia, that is mass into r square. I take a point particle. Now, I take moment about the point A. That is very important. What I observe? XA, YA, T and mg cos theta passing through A. I repeat, XA, YA, T and mg cos theta are passing through the point A about which I am going to take moment. And therefore, the moment is 0, since if there is a force P and moment is D, this is the point A, moment is P into D. But if the point A lies on the line of action of the force, then D 0. Therefore, moment is P into 0 and that is 0. Therefore, I realize since the four forces XA, YA, T and mg cos theta are passing through A, the moment of these four forces about the point A is surely 0. Two things are left. One is I alpha and another is mg sin theta. Let this length of the string be L. Since it is a point particle, radius is 0. What I have to do? I have to take moment of I alpha and mg sin theta about the point A. I alpha is a torque. Therefore, it is already a torque. I write I alpha plus mg force into distance, mg sin theta into the distance AB, that is L. I write it here. That must be equal to 0. Now, this diagram is absent in the book. In all the books you have read, you got the same equation but out of a wrong diagram. In engineering, we must be extremely careful. We may get the right result out of wrong way, which is of no exclusion, no importance in engineering. This very diagram is known as FBD, free body diagram. I repeat, this very diagram is known as FBD, free body diagram. Extremely important, without which we cannot solve any mechanical problem. Now I rub this and try to say something more about it. Learning is, I can get the right thing. This is I alpha was there. I write again here, I alpha plus L mg sin theta is simply equal to 0. I rub it very simply. I have to find out I. How? mr square. This is the point A. This is mg. Length is L. Definition of I is mr square. Therefore, ml square into alpha. Alpha is d2 theta dt2. Angular acceleration. plus L mg sin theta equal to 0. Now I divide both sides by ml square. If I divide this is by ml square, I also divide by ml square. 0 by ml square is always 0. This thing cancels. I write d2 theta dt2 plus g by L sin theta equal to 0. Now I put g by L equal to omega square. If you put the dimension of g, dimension of length, it will be radian per second whole square, angular velocity, plus omega square sin theta equal to 0, where omega equal to root of g by L. Now I write. At this point, we have many things to see. Sin theta, if you take theta 90 degree and then leave, it will give you a chaotic motion. Very important subject, chaos starts from simple pendulum. But remember, chaos is a very complex subject. Its theta versus t will be totally different than that of sinusoidal motion. It is not possible to solve. I can solve, you may say, I want to solve for all theta. I don't want to take the approximation that sin theta equal to theta, which I know in Taylor series. Yes, you can do. That our famous Indian Ramanujan also did it. And it leads you elliptic integral, a topic, a subject with which our Indian genius Ramanujan has enough and fantastic contribution. Third, which you know. I know Taylor series, sin theta minus theta cube by factorial 3 plus go on and on. Theta small and theta must be in radian. It must not be in degree. It must be dimensionless, as I discussed many times. I replace sin theta by theta. This is 0. Therefore, you now come to next point. I know this is extremely important result. T equal to 2 pi by omega. 2 pi by omega means root of L by G. You may tell, I know it from class 12. Is it the damage of time? I shall surely know my sons and daughters. I have told you from the very first, object being same, observer being different, the interpretation being changed. You see, I will solve it later on, but from this very simple thing, how many things and how many very important conclusions so simple, well-known result can give to us. First, I take log. If I take log, you too also, log a into b, log a plus log b, log 2 pi, it is useless to give the magnitude, plus half log L minus log G. I then take differential. You know the difference between differential and differential coefficient? One ddx of log x is 1 by x, ddt of log t is 1 by t. I write 1 by t and then dt. Taking differential, 2 pi is 0 equal to half. This thing gives you 1 by L into dl minus log g means 1 by g into dg. I wrap all these things and I write this thing here. dt over t equal to half dl by L minus dg by g. Now, three things again. This, if you know from mathematics, from class 12, if x is the variable, then dx is called the error and dx by x is called the relative error, together with the fact 100 into dx by x is called the percentage error. Relative error in measuring time period is simple this. Remember, if I multiply by 100, then it will give me percentage error. dt by t is the relative error in measuring time period. dt is the loss or gain. dl is the increment in length of the original length n. dg is the differential change of the acceleration due to gravity. Now, if g is constant, then dg equal to 0, then I get very simply dt by t half dl by l. Second, if L is a constant, then I get dt by t equal to minus dg by 2g. This is all over we get. Third, if dl by L is greater than dt by t, then relative error is positive. If dg by g is greater than dl by L, relative error in measuring t is negative. If dl by L is somehow numerically equal to dg by g, then it is 0. We have to go to the third order, and then calculus of variation, very important subject comes. These two things are very important. Third, is that all? Answer, surely no. Now, suppose I am taking this pendulum in a box and moving so slowly that the pendulum cannot understand it. It is giving the same period. This is the initial state. I am working extremely slowly so that it is not affecting time period. This is the final state. This is the initial state and this is the final state. The initial state does not know that I am advancing, but I can present the final energy and final state, final life period, final time period by using all the data of initial state. This fantastic important thing is known as adiabatic approximation. Adiabatic approximation. It is extremely important in quantum mechanics and nanotechnology. Well, if we read, it will give you Born-Oppenheimer approximation also. By knowing all the conditions of initial state, I can express every data of the final state, although initial state is not recognizing that he has reached to final state. This is really extremely important, and we can do. This is all over first stage. Second is, I want to solve it. Up to this, I told you a lot. I am very sure you know something of that, but not the totality. Obviously, you know many things. You also think many things, but not the everything which I am going to very simply deliver here. Now, let us solve it. You can also solve very easily. You did it, I believe, in class 12. Solution of differential equation. This is SHM equation. You also did it. But have you ever noticed? I have to first give the form of the solution. I am simply telling you, before solving this, I have to assume the shape of the final solution. If I can't assume it, I can't get it. In nonlinear differential equation, if theta is replaced by sin theta, this type of substitution is not valid. This gives you to your auxiliary equation. I can't get auxiliary equation if theta is replaced by sin theta. That is, if I do not want to do any approximation, if I want to get the result as such, generally approximation-less condition, then this substitution is not valid. It means before solving the differential equation, I am guessing the answer. This guessing is possible in linear differential equation. Had it been nonlinear, I cannot do it. It is not possible to do. And nonlinear means I can go to theta square, theta cube, theta 5, and our method will at once fail. If you do it, I need not do the differentiation, still I do d theta. I am taking here t as the variable, therefore d theta dt is simply a m e to the power mt, and this is theta m. I do again. If I do again, I get d2 theta dt2. This is, I again differentiate, m square will come, and theta is that, it will be m square. Then I replace it by theta and d2 theta dt2. I get simply m square plus omega square theta equal to 0. This you also know. You write down, that is why it is told, since differentiation of a exponential function, shape being same, only constants is being added. Let us take very simple d dx of e to the power kx. That is k e to the power kx. That is, shape is not changed, only amplitude is changing. This is another very vital approximation of us. We are doing it in general. And I get m square plus omega square equal to 0. Therefore, m equal to m square minus omega square, m equal to plus minus I omega. You know in class 12, if the solution is alpha plus minus I beta, then answer is y equal to e to the power alpha x a cos beta x plus b sin beta x, where a and b are two arbitrary constants that must be, since the differential equation is second order in nature. When I compare, I get alpha equal to 0 and beta equal to omega. I realize only sinusoidal part will stay, and therefore I can at once write my solution as theta a sin omega t plus b cos omega t, where a and b I have to find it out. Therefore I say it is sinusoidal. It can easily be written theta equal to c sin omega t plus minus alpha, or theta equal to d cos omega t plus minus beta. C is the amplitude, omega is the frequency, alpha is the phase. Phase means at t equal to 0, if I put t equal to 0, where from the particle starts? At t equal to 0. That is called phase. Extremely important consequence. When I go to communication, c is a function of time, amplitude, which is a constant here, known as amplitude modulation. Omega, which is a constant as a function of time, known as frequency modulation. Alpha, which is a function of time, known as phase modulation. Amplitude, frequency and phase modulations are extremely important in communication, which I have high hope you will read later on. Just have a 5 minutes coffee break. After then, we will return to us. Till then, I am looking.